Hello student, the question says in the circuit shown, the reading of the voltmeter and the ammeter are. So we have to find what is the reading of the voltmeter and ammeter for the given circuit. So this is the given circuit. And remember, for ideal ammeter, if nothing is given, we'll assume it's an ideal ammeter. So the resistance is zero. That means there is no resistance. And similarly, for ideal voltmeter, if nothing is given, if no resistance is given, the resistance is considered infinity. Infinity means basically this fellow can be assumed as short circuit. We can assume as though this circuit doesn't exist. That means how can I redraw this diagram? I can take this and I can just remove the this entire voltmeter part. So this entire voltmeter part I can remove in the circuit while solving the problem. Similarly, I can remove this ammeter and I can just draw a zero resistance in its place. Imagine a zero resistance in this place. I have removed this entirely. So this is how our effective circuit would become. And this voltmeter would only measure the potential difference across this. So whatever is the potential difference across this is what my voltmeter measures. This ammeter would measure the current I that is flowing in the circuit. We can clearly see when the current is traveling, it will split here two parts and again it will merge here. So let us find what is R effective here. If I try to find R effective of the entire circuit, these two are in parallel. So 100 would become 50. So R effective would be 100 would become 50, because when both are equal, R effective would be R by 2. In parallel, when two resistors are equal, R effective would be R by N. So 100 by 2, so it would become 50. Plus this combination is in series with the 100 ohm plus 100. So R effective would be 150 ohm. Once you get R effective as 150 ohm, the current would be equal to 6 by 150. So this will be the current that we will get. So our ammeter would give me a reading of 6 by 150. So 6 by 150, I can write 600 by 150 into 1 by 100. So this would be 0.04 ampere. So straight away, here I can stop, and the only option which is showing me 0.04 is option 4, so I can mark it. But let us continue this. When you have current I that is traveling, this path and this path are equal. We can clearly see that this path and this path are equal. So here I by 2 would flow, here I by 2 would flow, and these I by 2 would come here and merge, and we will again get I. Right now, I will not discuss in detail how we told that I by 2 would go. If both the paths are equal, the current would split equally. And current I is flowing here. I want potential difference V. We know V equals to IR. So V equals to I value is 0.04 into R value is 100. So you can directly write 0.04 into 100 would be 4 volt. So the voltage, the reading in the voltmeter is 4 volt. The reading in the ammeter is 0.04. But let us try to solve this problem in other ways. There is another method called voltage method. We will solve this using voltage method. Let us see what is that voltage method. I will remove this as usual. And this 100 and 100, they will become R effective 50. So I'll remove this. And in place of this 100 ohm, I will write 50 ohm. Okay. Now you can see these, let us say if current I is coming, these two are in series. We can clearly see that these two are in series. When these two are in series, let me call this V1, let me call this V2. We know in series, current would be same. If current is same, voltage is directly proportional to resistance. This method right now I'm doing is called voltage method. And remember, this might look like a lengthy method, but this method would be useful in other problems. So when voltage is proportional to resistance, I can simply write V1 by V2 equals to R1 by R2. So you basically get V1 by V2 is 1 by 2 and V1 plus V2 is 6. So this is called ratio. This is basically sum. If you know sum and ratio of two things, then V1 would be simply the corresponding ratio. What is the corresponding ratio of this V1? 1 divided by sum of ratio 1 plus 2, 3 into the total sum. So basically the formula goes like this: corresponding ratio divided by sum of ratio into the total sum of the quantities that we are doing. So V1 value would be 2 volts. If V1 is 2, V2 would be 4 volts. So directly we got the voltage as 4 volts from this. Once we get voltage as 4 volts and V1 as 2 volts, how can you find the current here? Current is very simple. Current is, you do anything by anything, you will get your answer. So basically voltage by 50. So it would be 0.04, or you can do 4 by 100, again you will get 0.04. So this is an voltage method. Even though you might feel that this is a lengthy one, but I still explain in voltage method because it is good to know both the methods so that you can use it whenever you need it. So the correct answer for this would be option 4. Hope you understood how I was solved. Thank you.